As we get closer to our ultimate goal, which is being able to graph rational functions, we have to look at one more kind of little discrepancy that can show up when we're going to graph rational functions. So we already saw that rational functions can have asymptotes, but they can also have what's called a hole in the graph. And it's literally a point that's removed from the graph. Point that is removed from the graph because that x value makes the denominator equal 0. And we know fractions can't have denominators of 0 because 0 in the denominator of a fraction is a number that does not exist. So when we're graphing our rational functions, we know if we looked at this picture of a rational function, we would have a horizontal asymptote right through here because I can see that the graph clearly breaks, and I can draw this kind of imaginary line right through here that never touches the graph. I also can see that I have a horizontal or a vertical asymptote right through here because again I can draw this vertical line right through here without ever touching the graph. A hole in our graph is literally a missing point. And when you graph on a calculator or you use Desmos, these holes are so super teeny tiny that they don't show up. We're only going to see them when we look at the equations. We'll be able to pick out where the hole actually is, but we want to make sure that when we're actually graphing, we show that we know where the hole is. So whenever we do that, we kind of over exaggerate it and draw a big open circle like I've done here in order to symbolize that there is a hole or a missing point in the graph. So let's talk a little bit more about what you have to do in order to find a hole. So your steps for finding a hole, the first thing you're going to do is factor the numerator and the denominator. After you factor the numerator and the denominator, you want to see if any factors cancel out. If there are any factors that cancel out or any factors that you could remove from the function, those are going to be the ones we'll set equal to 0 and solve to find the hole. So see if factors cancel out. Set removed factors equal to 0. Solve for x. So when we were solving for vertical asymptotes, we had to factor, and when things would cancel, we just kind of ignored them. Now that we know what a hole is, those things that we're canceling out, that's where we get our holes from. So anything that we're going to cancel out is the factor that we're going to set equal to 0 to get our hole. So let's look. We have a couple different examples here. If we look at the first one, A, it wants us to take y equals x plus 1 over x squared plus minus 1 and see if it has a hole. So the first thing we need to do is we need to factor it. The numerator, I know there's nothing I can do in the numerator, but in the denominator I see that that's a difference of perfect squares, so I can make it x plus 1, x minus 1, and I see right away that I have an x plus 1 in the numerator and the denominator. So if I were simplifying this, I would be able to cancel them out. So I take x plus 1, set it equal to 0, subtract the 1 on both sides. I get x equals -1. So my whole is at x equals -1. I do the same thing for the next one. I'm going to factor it. I'm going to set any removed factors equal to 0. And then I'm going to solve for x. So when I go to factor this next rational function, I notice right away I have 3x squared minus 2x minus 1. I have a trinomial where my a is bigger than 1. So I've got to use my bottoms up method. I've got to say, okay, 3 times -1 gives me -3. Factors of -3 that add to -2 would be a -3 and a +1. But then since I multiplied my factors by 3, I need to divide them by 3. I've got to do the same thing in the denominator, except for now I'm doing 4 times 3, which is 12, and now I need factors of 12 that add to 7, so I'm going to use 4 and 3, positive, positive. Here I multiplied by 4 to get these factors, so I need to divide them by 4. Now when I simplify, I get x minus 1 and 3x plus 1 over x plus 1, x plus 3x plus, 4x plus 3, because I got to bring my bottom up. I then notice that there is nothing that's the same. I have kind of similar factors here, which they were trying to probably trip me up with if I didn't factor this correctly. But nothing there is exactly the same. So because nothing is the same, this function has no whole. There's nothing that I can cancel out. There's nothing for me to set equal to 0, so there is no whole there. All right, let's try one more. Here I have 2x squared over, I'm going to factor this by saying what multiplies to -6 and adds to 1, x, 3, 2. I want a positive 1, so I want 3 to be positive. Again, I don't have anything that's the same in my numerator and my denominator, so I have no whole. You're only going to have a whole if you have factors in your numerator and your denominator.